Good morning, good afternoon, good evening. Welcome to Flat Earth School. The school is around us 24/7 since the beginning of existence. I'm Mitchell from Australia, merely a student, always questioning, always learning about the world around me. Our Flat Earth School, it is the best teacher anyone could ever hope for. I want to extend my appreciation to all my patrons, all the supporters, everyone who is liking and sharing the show. Please, I encourage everyone to please share and like the show. It's going to be a great show today. I've got a very special guest, Rob Durham. He has recently bring out a very killer video, a very devastating video for the globe, just demonstrating how we can never use the globe for celestial navigation, how it's never taken into account, how no one actually has a physical globe that takes with them when doing celestial navigation. And we're just going into everything about that today. Rob, thank you for coming on Flat Earth School. How are you, mate?
Thanks for having me, Mitchell. Good to be here.
Rob, the video, if anyone hasn't seen it, go to Rob's channel. I've linked his channel in the description. Please subscribe to Rob. He deserves a lot more subs, a lot more attention. If anyone hasn't seen it, go over to Rob's channel and view that video. But we're going to go through that live today with his AutoCAD model. Rob, how did you? What's the backing to this? Like, how did you come to this realization that we're not actually plotting things on a globe? We're actually plotting things on a flat map. Like, where'd this whole story come from, mate?
Well, I don't know if you're aware or not, but I've been in Flat Earth since 2015. That's when I put my first video out. I work with AutoCAD professionally, and I have done for over 20 years. So I started doing some modeling probably 2 or 3 years ago with the globe and wrapping the Mercator projection around the globe just to check angles to stars and such like. And then I kind of had a break. I didn't really do anything for a couple of years, and then I wasn't active in the community, but I was very sort of passive. I was watching everything, keeping up to date with everything, and specifically the Flat Earth debate. I was very interested in that, and when the sextant topic came up, it got me to thinking back to when I was wrapping Mercator projections around the sphere, and I just something spurred me to sort of try and see what would happen if you if you drew a circle on the Mercator projection map and wrap it around a sphere. I knew it was going to be distorted, but I didn't know to what degree or to what it would actually look like. So yeah, that's pretty much what inspired me to do it.
Yeah, I think everyone's pretty stoked that you did, because it is beautiful. It is beautiful what you've done with the AutoCAD model. Obviously, you've said that you're very comfortable using AutoCAD. This isn't the first time you've used it. You've been doing this for a while, but it's kind of upon seeing arguments like the sextant. This is why I say I encourage everyone, if you don't understand the sextant, if you haven't looked into it properly, look into how the sextant works. Look into celestial navigation, because if more people do that from the flat Earth side, you get more angles of attack, more perspective. Like Rob has got here, he thought of something that no one else has actually thought of before. He's brought it to the table, and it is such a killer point. It is so devastating for the globe. Before we get into that, Rob, you said you've been into flat Earth since about 2015. What was your awakening journey? What made you first question your reality, I guess? Obviously, you believed that you lived on a globe in the first place, growing up through your schooling, up until what point? What made you question the globe, do you think?
Well, I kind of, I don't know if it's the correct expression, woke up in 2012. My younger brother actually was the one that woke me up into the deception and the lies going on, not just about the shape of the Earth, but everything. And in 2015, he just said to me, "Hey Rob, have you looked into the flat Earth?" I'm like, yeah, you've convinced me of some stuff, but flat Earth, that's just a little bit too far. Anyway, I went and watched
So
a
it's
video.
actually your brother.
Yeah, I watched a Mark Sargent's Clues, and then obviously out at the bays and gerunds, and yeah, that was it. I mean, I wasn't completely convinced straight away. It took me a good few years to be absolutely sure. I mean, I'm still not absolutely sure. I know it's not a globe. What the actual shape is, it appears flat. That's how it presents itself to us. And I suppose with this new sextant proof, it is looking more and more like it is flat. So yeah, that's how I came to the realization.
Yeah, I mean, like for you, what possibilities that it could be a globe is left in your mind? Like, what's I don't want to expose any kind of weak points in your understanding of our world, but like, what do you think is holding you back? Because I like to ask that to people because for me it was the stars for the southern pole rotation. I was uncomfortable with that. I didn't have an explanation with that for that, but upon realizing that my mind was kind of still in the globe mentality, in the heliocentric mentality, I had to bring myself away from that, thinking that when looking south at the southern pole rotation, that I'm looking at an axis, that I'm looking at a southern pole rotation. I had to bring my mind out of an antipodal view, because upon everything else in my reality presented as flat, the black swan, we can see too far, we never experience or view Coriolis, gas pressure without a container, all that stuff I was really comfortable with. But upon looking at the stars, I still thought that maybe it could be a globe. But there are just some things that I realized you just have to be comfortable with not knowing how it works. But it always happens. Just because we don't have an explanation for something that is happening in our world doesn't mean it's not happening. That's the thing that the globe believers don't get. We don't have to have an explanation for absolutely everything. As long as we can view it, as long as we can see it, if it's in our reality, it's happening. We don't have to go into imagination land like they are with the globe. So once again, not to expose anything that you don't want to, Rob, but what do you think is left to be answered for you to confirm that we are definitely living on a flat Earth? Do you think?
There's not a lot, to be honest. One thing that's perplexed me quite a lot with this realization of the sextant is the fact that it works on the Mercator map specifically. I know it does. They do say it works on other maps, but specifically the Mercator map is used quite a lot, I believe. So I don't know. It's the looping Pac-Man model, isn't it? It's,
yeah. So
obviously
you're not really a subscriber to the AE model.
I was, and I'm not dismissing it. I mean, at this juncture, I have no idea. All I know that for sure is that it's not a globe, and this demonstration that I'm going to show you shortly, I think proves it. It absolutely proves it. For once, I can say that this absolutely proves it.
That's brilliant. I love that way of thinking. You get to a point where you definitely know it's not a globe, and then you can actually have for everyone in the audience, this is the point where you need to get. You need to prove to yourself that it's not a globe, and then you can investigate what it could be. Because if everyone did that, then we could figure out maybe where the hell we live. Because up until this point, I don't know the layout of the land. All I know is, it's definitely not a globe, and it's definitely not I don't think it's an AE model. There is just too many things wrong with the AE model. One, it's a globe projection anyway, which doesn't line up with reality. It's not even used for that purpose of distances, layout of the land, that sort of thing. It says in the Gleason's map, in the AE map, it's only for positions of the sun and that sort of thing. Like it's not even for what the globe try to strawman's in. They say that this doesn't work on a flat map when they put the picture of the AE map up there. Where there's very few people that are actually saying this is literally where we live. It's more of a tool to get people out of the mindset of the globe, out of the mindset of that we're living on a spherical surface. It could be something else. It may not be this AE map. It may be something else, but that's what we're investigating. All right, so we may as well go into. Are you comfortable sharing screen now?
Sure, yeah. Give me a sec.
I'll bring that up. So that's already shared. So this is the view that we're going to see. So this is what's this, Rob?
So you see my cursor moving here?
Yes, yeah. So this is what the Mercator map, is it?
This is the Mercator map, yeah. So this is a image file. So it's a raster image just downloaded from Google Images. And first of all, it is common knowledge that the Mercator map distorts, or it is distorted the further away from the equator that you get. The more north or south that you get from the equator, the more it's distorted. And I wanted to just show, first of all, if I click this image here, I've scaled it within AutoCAD. So you can see here that the width is 24,875. That's AutoCAD units. So you could just say that they are miles. And obviously the height is exactly half of that. So that the 24,875 is obviously the circumference of the globe. So that's left to right. And the height is pole to pole is exactly half that. So if you multiply those two numbers together, you get 309 million square miles. Okay.
So that's the area of this map, the Mercator map.
That's the surface area of the Mercator map, yeah, is 309 million square miles. So if we just round that down to 300 million, yeah. If you take the surface area of the globe, which is the formula for the surface area of a sphere is 4 pi r squared, which works out to 197 million miles squared. So that's a difference.
Surface area of a globe.
The surface area of the globe, yeah, 197 million. So if we round that up to 200 million square miles, that's a difference between the Mercator and the globe of 100 million square miles. It's actually 112, but let's round it to 100 million square miles of difference. So that's how much surface area of a Mercator projection that you have to lose to wrap around a sphere, which is a huge amount.
Oh, that is massive. So just get that into perspective. The surface area of a globe was rounded up about 200 million square miles, would you say?
Yeah.
So that's an extra 50% that they're dragging out of nowhere to put it onto a flat map. An extra 50% of that globe surface area has now just become available and obviously distorted onto the map that we're seeing here, the Mercator map. So this map has a surface area of 300 million square miles. That's amazing.
Exactly, yeah. And obviously that surface area has to be removed, and the more of it gets removed from the south and the north, and then it's like an exponential function as you get back towards the equator. So yeah, that's why the teardrops are formed on the globe when you wrap it around it, because it's the further north it is, the more it has to lose.
Yeah, the further north or south, that's where extra 50% from the globe, that extra 100 million square miles has had to be elbowed into this map. That's amazing. And we've had a bit of after some globers have seen your first video about the teardrops of the circle of attitude, which we're going to go into after a bit after this. We've had a rebuttal saying that we don't use the Mercator map for navigation, but upon making that video, that certain individual didn't actually give us what map we actually use. So, and until you tell us, globe believers, what map you use for celestial navigation, we're just going to assume you use the Mercator model. So we'll keep going with this, Rob. And then if we are given a different map, obviously you can put this into your AutoCAD. We can go through the same process, and we can see how it doesn't relate to the globe in the same process.
Yeah, it's immaterial anyway, because if it's a flat map, it has to be distorted if it's gone away. If it's been projected from the globe to flat, every flat map has got distortion in it. You can't get away from it. You can't draw a circle on a flat map that's been projected from a globe and expect it to form a perfect circle when it goes back onto the globe.
Well, that's the thing, isn't it? We're not actually starting with globe measurements, we're not starting with a spherical surface, a curved surface when we're measuring maps. All maps here in reality for navigation, for layout of the land, they're all measured on this ground that we live upon. And using a total station, using a theodolite, they're angle measuring devices, similar to sextants. And we can measure distances, we can measure angles with these things. And that's how we have actually come to forming these maps. They're all flat earth maps. We measure the layout of the land. They all have horizontal baselines. They all have angles, obviously, when measuring terrain. So they can only be measured on a flat surface. They're all flat earth maps. So any map that we use for navigation that's been measured from the physical surface of the earth, none of that has any globe consideration, curvature consideration. We never physically measure any curvature. So they're all flat earth maps. They're all measured on a geometric flat plane. And so let's continue with this demonstration, Rob. This is the Mercator map. This is you've got what a circle of equal altitude. I just want to define that circle of equal altitude, if that's all right. So a circle of equal altitude on the Earth is the focus point of all points equidistant from the substellar point of a celestial body. So we've got the GP. You've got GP in the middle of that circle. So we've got a radius from the GP to the extremity of the circle. All points on that circle are going to be equidistant to the substellar point, which is the GP point. That's what a circle is. It's got the same radius. It's all points on that circle is going to be equidistant to the center of the circle. The altitude of the celestial body measured from any point of that circle is going to be the same. That's why it's called a circle of equal altitude, also called a circle of position. This is impossible in a sphere. You cannot get angles on a curved surface. They claim that they have a bent radius line, but obviously we've got a circle. It's a flat circle. It's a flat surface. It's an area of equal altitude. That circle there, everything within that circle that we measure from any point on that circle to the GP, to the position of the star, that's all absolutely flat. That area right there is absolutely flat. That's just what a circle of equal altitude is. So we've drawn this. You've got this on the Mercator map, Rob. Let's go into what we're doing here.
Okay, so as I said earlier, this is a raster image that's just been imported into AutoCAD. What I've done is I've drawn an actual AutoCAD element here, a circle element in, just to show. Just select it, singulates, just to show the radius. So the radius is 2,500 miles. Yeah. So if I delete that entity, this now is the circle that was drawn in a photo editing software. Yeah. So this circle is actually embedded into the raster image. I can't select this as an AutoCAD property. Okay. So this is actually this circle is actually embedded into this image. Okay. So I just want to just examine some of the locations that this passes through. So here on the southern tip of West Africa, and then it goes up through Africa. It crosses this sort of body of water, crosses this little body of water here, and it goes up through Russia and up through Finland. It just skirts this set of islands here. It skirts the south coast of Greenland, southeast coast, and then the rest of it's in the sea until it comes over these little islands here. And then it cuts across the corner of this sort of green area of Africa and returns to this part, yeah? And these, I just wanted to point out that specifically on land masses or land, the position of this line is geographical. So this can be passing through cities or towns or whatever. How do I explain it? The angle to the star or to the celestial body from any point along this circle has got to be equal to that same star, hasn't it?
Yeah, exactly. Yeah, that's what. Yep,
on this flat
definitely
map.
agree.
And these are all. My point is that it's harder to sort of judge when you're out in the sea because one bit of ocean looks like another bit of ocean. But when you're on the land, this is actually passing through geographical locations. Okay, so I just wanted to make that point before we move on to the sphere. So let me switch to the sphere now. So this is what it looks like, the circle, when it's wrapped around a sphere. And if we go and look at the locations again, so obviously the southern tip of West Africa, it crosses that body of water, it crosses this body of water up through Russia, up through Finland, it skirts around that island, and it comes back around underneath Greenland, and then the rest of it's ocean, and we go over those islands, and we go through this sort of green patch of Africa again. So the geographical land masses that it passes through is identical. However, it's obviously no longer a circle. And the implications of that is quite mind-blowing, really, because if I show a globe circle here, if I select this circle here, this one, you can see that I've drawn it as to a radius of 2,500 miles, which is the same radius as this red teardrop shape was when it was on the Mercator projection. But you can see how much smaller it has become. You can fit the whole teardrop inside this circle of equal altitude. And this is obviously the result of that reduction of size of map from Mercator to globe. It's had to remove all this land or this area, hasn't it?
That's fantastic. Anyone who realizes what they're seeing here has a massive smile on their face. This is what the globe believers think they're doing with the that yellow circle there. They think that they're plotting straight onto a globe when doing celestial navigation, when doing plot points after using a sextant. You are never doing that. As Rob just demonstrated with the Mercator map, we're using a flat map to draw the circle of equal altitude. That's the circle. And then if we transpose that onto a globe with the dimensions of what the globe is, this is what we get, a teardrop. These are globe tears right here. That's why I've titled the show Salty Globe Tears, because this is what we get when we try and put that plot point from the flat map, because all maps are flat, all maps are measured as flat. We try and put that onto a globe to consider what we're doing onto a globe, because we never plot onto a globe, we plot onto a flat map. This is what happens. We get these teardrop shapes, and Rob's put that circle of equal altitude, what it should be. It is so far from what it should be. And obviously, Rob, we haven't got a single radius point anymore on that teardrop.
Nope.
No, it's not.
The radius is different all the way around. Well, it hasn't got a radius. It's not a circle, so it hasn't really got a radius.
No, it hasn't even got a radius anymore. And obviously, like, this is kind of a looking down from the GP of the star. Not only does it not have a radius, a straight line from the extremity of the circle to the center of the circle where the GP is, the radius now, if we do draw a straight line from any extremity of that circle to the GP, it's now a bent line. You've now, if we're trying to make triangles on this, the adjacent is now curved. A radius is never curved. We never have a curved radius. We only ever have a straight radius. So there's just so many things that are impossible when doing celestial navigation, when taking into consideration a curved surface or a globe. It is just impossible to do on a globe. That's what Rob's showing here. We don't ever take into consideration curvature, take into consideration a globe when doing celestial navigation. It just does not work. There is no need to bring a globe into it, because this is what we get here. We don't get a circle of equal altitude. We don't get our positions accurately. You can't navigate on a globe. It's over just looking at this. But obviously, there's more things we're going to go into, Rob.
Yeah. So 10th Man linked a video to me where there was a guy doing an actual demonstration of this using a 3D model, and he was actually simulating like we've just done and drawing circles straight onto the globe. And he was demonstrating how at each point along this circle to the celestial body, the angles are the same. And what he hadn't done was taking it like I've done and taking it from the flat map and transposed it onto the globe. He was just drawing circles like this yellow one straight onto the globe. And yeah, if he draws a circle like this and draws lines up to this up to this celestial body, they are all going to be the same angle. But I thought it would be fun if we actually went and just actually did this on the globe, you know, as if we were in a boat and we was actually trying to locate our position, and we were actually using a globe to do it. So we were drawing the circles straight onto a globe, and I was just wondering how that would look. I mean, it's a moot point really, because that's not what we do, but I just thought, just for fun, we'd see what would happen.
Yeah.
So this circle here is actually the 2,500 mile circle, but it's pressed down onto the place where it meets the surface of the Earth, if you see what I mean. So there's the GP. So coming out on a flat plane out, you've got 2,500 miles, but obviously to draw a circle on a globe, you would have to draw it down here. Now, I don't know if when you was at school, the way I was taught to use a compass for drawing circles, you know, you get a ruler and you put your compass on, and you put the point of the compass on the 0, and then you open the compass out and you put your pencil on the radius value on the ruler, and that's how you get your circle drawn to the correct size.
That straight measurement, you're never doing it on an arc. You're not measuring that distance with the compass on an arc. You're measuring on a nice straight line.
So if you was to do it on this globe and you was to put your point of your compass here and you was to draw the circle all the way around, well, where would you do it? If it's 2,500 mile radius, then you would have to angle the pencil down. So this would angle down. This line would angle down here, and it would come to here somewhere. It wouldn't come straight down to this point, would it? Do you see what I mean?
It'd be less, wouldn't it? Yeah, you wouldn't
slightly less. So where exactly would you draw it on a globe? I mean, like I said, it's a moot point really, because the red line is the actual line.
Yeah, that's the actual line that we've drawn on the flat map, and we've just transposed it onto the globe. But when globe believers take us through how we do celestial navigation, and they think that they're doing it on a globe, this is what we see. We see the orthographic view. We see that top line there, that top radius, a tangent plane, if you will. They say that to have angles, to attain angles, in the first instance, we have to have that horizontal tangent plane. They're saying that because we have a spherical surface beneath our feet, the tangent plane is just touching at one specific location. So to have 90 degrees, to have any angles from any positions, you have to have that horizontal baseline. And right there, welcome to flat Earth. You need the horizontal baseline. You need that flat adjacent. But they like to also put that second line there when just looking at plot points on a globe. That second line circle beneath that tangent plane, that's how they represent the plot points on their globe. But you can't do that. You can't transpose that horizontal tangent plane onto the surface of the globe. You're never going to get an angle when using a curved surface. You're going to have a curved adjacent. You're going to have a curved line trying to measure an angle. It does not compute, does it, Rob? You can't get an angle from a curved line.
Indeed. And I'll just show you, let's go into something else. I'll show you, let's turn some stuff off.
And this is fantastic. This is exactly what we need. We needed to model this in a 3D aspect and do this live. This is fantastic stuff, Rob. I really appreciate you coming on and showing everyone how they think that they're doing it, but how it can never work on a globe.
No worries.
Brilliant.
Oh, let me just turn the circle on again. That one. I'm just going to delete that one temporarily. Okay. So what we've got here is position 1. We're going to say that we are on this southern tip of Africa. Okay. That's where the flat Mercator projection circle has triangulated our position to. Yeah. Say we've done 3. We've done 3 sightings, and that's where we've discovered that we are on this position here. Yet the circle here is the perfect circle on the globe. If I just, it's what we was looking at a minute ago. Okay. So if I go back to this view. Okay, so we're at our actual. Hang on, which one was it?
And
Yeah,
this is like, yeah, that circle there, that yellow circle is when the globers get a globe, like a spherical surface, and they put something like a cup on it, and they say, look, you can put a circle on a globe. It's fine, you can do that. But yeah, go through what they're doing, Rob.
Yeah, that's not what's happening though, is it?
No.
So the observer position here is, or the actual location is here on this red line. So this is that southern tip of West Africa. And the angle to the celestial body from there is 26.5 degrees, okay, from this position.
And that's if you've got the horizontal, the tangent line, the tangent plane, if you will. So they have to have that horizontal. That's the only way they're getting an angle there. Yep.
It's the only way they get an angle. So on the globe, it's 26.5 degrees. The yellow line, which is the actual circle, as if you was putting a 2.6 degrees. Okay.
You're roboting a little bit.
Oh, sorry.
Just say that point again, Rob. You're roboting a little bit there.
So
with the second angle.
Yeah, the second angle, which is the yellow, the actual circle, which is like the cup placed on the orange. That is 22.6 degrees. Okay. So that is the position. That is the two positions. One is the position that was transposed from the flat map, and the other one is the actual circle that we've drawn on the globe. Okay. So that is, if we just get a bearing of where we are, we're on this southern tip of Africa here. What I decided to do is pick probably the worst case where the teardrop shape deviates from the circle, which is probably around here, the biggest distance here. So let me just.
Yeah, I mean, you can already see that is a massive difference. That's brilliant.
Yeah. Just go to view 2.
So yeah, where's the radius, globe believers? Where's that equidistant point on this teardrop? You don't have it. You don't have one radius anymore. You don't have a circle anymore. You've got a teardrop, a salty globe teardrop.
So this is just to highlight the point. The circle obviously is 22.6 degrees again, and it is going to be 22.6 degrees anywhere around. Wherever I did an angle around that circle, it's going to be 22.6 degrees. And that's the circle that the globers think they're doing their sightings from. In actual fact, the red line here is 41.8 degrees. 41, I can't remember, what was it, 26 degrees from the other location.
Yeah, it was in the 20s. That is, yeah, it was almost double the angle. So on that point there where it is, it has the shortest distance from the GP to the extremity of what they thought was going to be the circle of equal altitude on the flat map, put it on a globe, look what happens. It turns into a 41 degree angle instead of a 22. It is so far off what it is meant to be.
26.5, wow. 41.8. And obviously the 22.6 is the same. It'll be the same anywhere around. That's what they think they're getting. And in actuality, they're getting the red if it's on a globe.
If it's on a globe. And obviously the circle of equal altitude, no matter where you are on that circle, you're meant to get the same altitude to that star. That's why it's a circle of equal altitude. You don't know where you are on that circle. Well, you kind of do because you know where you're leaving from. But just say if you dropped in the middle of the ocean or dropped in the middle of a bit of land, you don't know where you are on that circle. Wherever you are on that circle, well, yeah, any position on that circle should be equidistant, should be equal angle, equal altitude. But as Rob's just shown here, any part of that red circle there that has been plotted on a flat map and then put it onto a globe, every single point on that circle is going to be different altitude. It's meant to be the same.
Do you see the arc that's highlighted here?
Yep, that curved adjacent. Brilliant. That's what I was talking about there, the curved radius now that we never have a curved radius.
1,779 miles. What it
Yeah,
should be
that's
2,500.
you can see how distorted it is. Yeah, and then obviously the yellow circle, that is the 2,500 mile mark, isn't it?
The actual arc length is 2,700 because it's an arc, not a straight line.
Because it's an arc. Yeah, exactly. It
It's
does not
actually
work on a.
2,700.
Can you see problems here, globe believers? Do you still think you're doing celestial navigation on a globe? We never ever. The point is, we never ever plot anything to do with celestial navigation directly onto a globe. We don't. Mariners don't hold a globe under their arm, go out to sea, and plot things with a compass and a square on a globe, because it doesn't work. You can't use those tools, a compass and a square, when using navigation. We have to use a flat map like the Mercator map. And that's what the red line was. We plotted the points. We got an angle using the sextant. The sextant is an angle measuring device. We got an angle to the celestial body. We plotted the area, the circle of equialtitude on the flat map. And then if you want to take into consideration the globe for whatever reason, for whatever delusion you want to put yourself into, this is what happens. It doesn't work on a globe.
Yeah, there it is.
It's over right there. I just want to go into what Quantum Eraser. He has 3 easy steps for. This is for flat earthers to follow when we're talking about celestial navigation with the globe, or celestial navigation to begin with. This is the official end of the ball-tard spinning space monkey religion right here, says QE. Follow these 3 easy steps. Number 1, ask sexts by mariners to successfully navigate using the relationship between the Earth's surface and celestial bodies. Obviously, yes, that's what we do. We use the sextant to navigate using the relationship between the Earth's surface and celestial objects. Obviously, we're not doing that on a globe. We don't have a curved surface beneath our feet. We can't attain an angle. Number 2, are sextants used to obtain elevation angles from your position to celestial objects? Yes, that's what a sextant does. It is used to obtain an elevation angle from your position to a celestial object, as Rob's shown on the Mercator map. That's what he did. That's what he plotted on. And number 3, can you obtain an elevation angle? This is what, if we think we're starting on a globe here, as Rob's demonstrating here, if we think we're starting on a globe, can you obtain an elevation angle from a curved baseline, a curved adjacent? No. Welcome to Flat Earth. It's over right there. If we think we're starting with a globe, which we never do with celestial navigation, if we think we're plotting this on a globe, where are we getting the angle from? It's over right there. We don't have a curved adjacent. You have to put, as you've put. Go on, Rob.
Do you want me to demonstrate that again?
Yeah, definitely.
So angular dimension from here to here. Obviously, that gives me, it's rounded up on this particular one. But if I go from here to the curve, the arc, where's it gone?
Why didn't that work, globe believers? Why can't we select that arc value? Why can't we select it to get an angle? Why does it only work when we select that straight line and the horizontal line? Why can't we select the curve?
There you go. Object selected is not a line.
It's over.
Or as Adam says, computer says no.
Computer says no, and you get a big cough in your face. This is brilliant, Rob. If you haven't realized it by now, globe believers, we're not doing celestial navigation on a globe. We can't attain an elevation angle on a curved surface. Look what you have to do. You have to think. You have to make a horizontal plane, a tangent plane. That's what the 22.6 degrees. That's what it's measured from, and horizontal tangent plane. You think it's a tangent plane because you think you're still living on a globe. We measure that angle. We've got 22.6 degrees on the flat surface. But if you think you're doing it from a curved surface, you can't attain an angle of elevation on that curved adjacent. That's the housekeeping question in the flat earth debate right now. Is there any evidence? Show us a curved adjacent when attaining an elevation angle. It is impossible. That's why you have to put that horizontal plane on there. You need the flat baseline. As Rob's just demonstrated, you can't even attain an angle on the curved surface, can you, Rob?
Nope. It's impossible.
It's impossible. That is brilliant. Love this stuff. And this is just what we do with celestial navigation. We plot it onto a flat map. That's what you have to do in the first instance. If you think you're plotting it on a globe, you can't do it. You can't use those flat Earth tools. You can't use the sextant. You can't use the compass. You can't use the square. But you have to when you're using celestial navigation. Like this demonstration here, Rob. This is brilliant.
You know, Mitchell, you know, if you got this in a math test at school, you know, if you had a triangle and they showed you, they drew a triangle like this, so it follows that yellow line, then that white line, then this yellow curve, and they give you an angle, they give you one angle and one length, and say, work out this angle. How exactly would you do that?
Yeah, well, you're using straight lines, aren't you? You're never using a curved adjacent. you have to use that straight baseline.
The student wouldn't be able to answer the question.
Well, it's not a question
impossible.
that is no, it is an impossible question. You'd be scratching your head. You'd be is this a quick trick question? Yeah, it is.
Yeah.
You're pulling my leg here. How can we do this? I mean, like, and let's go to the 90-degree angle. So we're meant to have a GP point from the star to the surface of the Earth. Can we obtain a 90-degree angle using those two lines, if you will, the curved adjacent and the GP right there? Are we attaining a 90-degree angle there, Rob? Straight line. And once again, what does it say there, Rob?
Object selected is not a line.
How are we getting a 90-degree angle on a curved surface, globe believers? That's what it says in all the almanacs. You've got a 90-degree angle. You've got a GP point to the star. Any given time, you've got a GP point from the star to the surface of the Earth. The surface of the Earth just isn't curved. You can't get a 90-degree angle on a curved surface.
No.
What else did you want to go into, Rob? Is there some other things you want to go into?
No, I think that's about it on that demonstration.
Did you want to bring up the demonstration that I requested we go into with the
Sure,
those separate
yeah.
layers?
You have to run me through that one.
Yeah. This is brilliant, Rob. Thank you so much for coming on there. Yeah, 10th man in the chat says object selected is not a line. No, it's an arc. It's a curved adjacent. You can't obtain any angles, any angle of elevation with a curved adjacent. So when we're actually doing celestial navigation, yeah, we'll use this angle. So if that GP point of the first star in going directly to the center of the globe, on top of the globe, if you will. So if that's your zenith, over to the left-hand side, Rob. So put your cursor. Yeah, okay. So if that is, and forget about the star above his head, but if you are at that star, you are at the GP point of that star. So if that is your observer point, that's where the person is standing. You've got the star 90 degrees above your head. So, and then star 2, you've got somewhere out in the distance. You're trying to, obtain an angle to that star. So from the GP point, from your zenith, you have to obtain a 90-degree angle from your zenith. That is the horizontal plane that you think is a tangent line. But upon doing that, in every single example of celestial navigation, the GPs of all the stars are parallel. And that's how we do celestial navigation. All the GPs of that star. So it's star 1, that's 90 degrees. That's a straight line down, vertical. Star 2, over to the right, 90 degree down. That's vertical. If they're parallel, look where the GP point would be on a globe. It misses the surface of the globe altogether if they are parallel, which in every single case of celestial navigation, they are parallel. They're not curving away from each other. That other line that you've got from the GP of the second star to the center of the presupposed spherical Earth, you're not getting a 90-degree angle there. It's not parallel. That's not how celestial navigation works. We have to treat everything in the sky as flat. Every GP point of every star that we use is parallel to each other. They're all vertical. The globe believers want you to believe that, they're all tilting away from you at all different angles. That's not how celestial navigation works. You have to treat everything on the ground as flat, that horizontal flat baseline. You have to treat everything in the sky as flat, a celestial flat plane, if you will. That's the only way we can attain angles. That's the only way the celestial navigation actually works. You can see the GP point of that star too. That'll miss the Earth altogether. And obviously, you draw more stars around there. So what's the radius of that tangent plane there, Rob, that we've just drawn to the to 90 degrees to that? Yeah. So obviously, if we have a distance,
6,152 miles.
So you can see anything, any distance greater than 3959 miles, it does not work on a globe. So any distance from the observer to the GP of a star, which can be thousands and thousands of miles. Yeah, in this case, we've just randomly plotted 6,152. Yeah, so and that is a GP distance from the observer to the star that is obtainable here in our reality, in Earth. So we're measuring an angle, whatever the angle may be, from the observer to the star, and we're deducing that that distance to the GP of the star, in this case, is 6,152 miles. If that's the case, the 90 degree from the horizontal to the GP, that's a 90 degree right there, where those two lines meet. That's the only way we can attain a 90 degree angle where those two lines meet, because they are straight lines. The GP, where it's meant to be touching the surface of the Earth, if it's a globe, it misses it. It goes off into space. It is, you can't attain a GP of greater than a distance 3959 miles on a globe. It goes off into space. And if we're in the north, if we're in the south, a lot of the time the sun's GP is going to be greater than 3959 miles. It's going to be thousands and thousands of miles away from us. And if it is greater than 3959 miles, look what happens. It doesn't even touch the surface of your globe. It has to be flat. Get rid of that sphere beneath your feet. You don't need it. It is all done on a flat horizontal, a flat adjacent, a flat baseline. That's what we need in every instance. And if you can't see that by now, you're highly deluded, aren't you, Rob?
Precisely, yeah. And you will be miles off course if you plotted it on a globe.
I mean, that's where you have to take it. Like, if you think you're doing celestial navigation on a globe, you're not going to get any locations if you're using a globe. If you're plotting on a globe, do you know of anyone that's ever plotted any of these on a globe when using a sextant, Rob?
Well, I don't know anybody who uses a sextant, but nobody, as far as I'm aware, nobody does it. They all do it on flat maps. They don't carry globes around in the vessels as routinely. They do it on charts, navigational charts, flat charts.
Exactly. And we're going to get 10th Man and Adam Meakin on Friday on Flat Earth School to go over a bit more about using the sextant, using our reality, just what we're going to be doing with the sextant. And 10th Man's going to detail with references to all the information. He has so much information, and 10th Man has really sparked this discussion. 10th Man is pulling the strings here. He's got all the resources. He's watched all the videos. He's got 2 sextants now. He goes into such detail about what we're actually doing when using a sextant, when doing celestial navigation. He's going to highlight this. No mariner takes, as Rob just said, holds a globe under their arm when going out in the ship to do celestial navigation. It's not something that a celestial navigator uses. It is all flat maps. And could we go back to the Mercator map, Rob?
Sure, yeah.
That's what we need to do. That's what we're doing when doing celestial navigation. We've got that area of equal altitude, that circle of equal altitude on the flat map. That's what we plotted on, a flat map. And then it works. That's how we do it. We don't do it on a globe. We don't use a compass and a square on a globe. No, we're doing it on a flat map. And then what happens when you try to put it onto a globe, Rob? Do you want to go back to your you can get rid of mine. I was just making that example. But yeah, as Rob demonstrated so brilliantly, when we put that, if you want to take into consideration anything to do with a globe, you get these salty globe tears. Look at that. Where's the circle of equal altitude again? Globe believers, the points that are equidistant from the GP to the extremity of the circle. Non-existent.
Yeah, and just to hammer home the point, these are geographical locations.
Yeah.
These red lines pass over, and they will all be different angles to that. If you actually do this on the globe, they will all be different angles and different distances to that celestial body.
Yeah, I mean, if you think you're still doing it on a globe with a horizontal plane baseline, not a curved adjacent, because obviously you can't get an angle with a curved adjacent. If you think you're doing it on a globe in those positions, as Rob's just demonstrated right there, it's meant to be a circle of equal altitude. It's meant to be equidistant from the GP to the extremity of that circle. It's not. It's a teardrop shape. Rob, this has been brilliant. Thank you for so much for coming in and demonstrating this live. Like, this is... The globe's over. Like, we don't use the globe with celestial navigation, do we?
Absolutely not. How could you? You'd be miles off course if you did.
I mean, yeah, you'd be hopelessly lost if you thought that you were plotting anything on a globe. If you thought that you use a globe for celestial navigation, it's all done on a flat map. Flat maps are always measured from reality, from the Earth right here. Never take into consideration any curvature. That's why it doesn't work when we wrap it onto a sphere like Rob's done. How much more surface area was there, Rob, from Mercator to a globe, or less?
Approximately 300 million square miles on the Mercator and 200 million square miles on the globe. So a difference of 100. It's actually 112 million square miles, but yeah.
More than 50% you have to get rid of from Mercator to a globe. That's outrageous. Like, where's all those points gone that you thought you had on?
But it's a third that you have to get rid of, isn't it?
Well, a third going from
from
Mercator to a globe. But if you're starting with a globe, you have to, what if you're going from a globe that they think that they're living on the first instance, you create an extra 50% from the globe, 200 million square miles. Yeah, from that. And in your video, I like how you put it. They think they're living on a globe, so we have to take it from the perspective as if we're doing this on a globe, right, Rob?
Yeah, it has. If we're living on a globe, it has to work on a globe. There's no two ways about it. It all has to start from the globe if that's what we're living on.
Yeah, it has to start from the globe. And if we're trying to start from the globe, this is what happens. It doesn't work out. It only works on a flat map, on a flat surface. In every instance, the globe isn't taken into consideration when doing celestial navigation, when plotting your position. Globe just isn't used. This is fantastic. So, is there anything else you want, any other points you want to hammer home, Rob?
No, not really. Just to say that this is, to me, this is probably one of the best proofs that we're not on a globe.
Absolutely,
in my opinion.
It's
a tool that's used routinely, and used with in conjunction with a flat map, and it will not work on a globe. Categorically, will not work on a globe. It's over. As far as I'm
screen
concerned.
right now. Yeah, salty globe tears. That's what's coming out of the globe. That's what's coming out of globe believers right now. If you understand what is actually going on here, you don't use a globe for celestial navigation. You cannot use a globe for celestial navigation. But you have to if you think you're living on a globe. No mariner has ever used the physical globe to plot any points on, because they know they need that flat horizontal baseline. So you have to do it on a flat map. You don't have. It's not like you. Imagine if they were trying to do it on a physical sphere. Like, you've got a sextant, you've got your artificial horizon, so you've got your flat horizontal line. You think it's a tangent plane. Try to transpose that onto that physical sphere that you've got in front of you. Like, do you reckon they have like flat, straight rulers that they're trying to obtain the angle? Like, it's just such, man. There's nothing you can do to put this onto a globe.
No, it's dead.
It's dead. It's as I said, the Black Swan, January 1st, 2020. That absolutely killed the globe. The globe's been dead since then. This, when using the sextant for celestial navigation, we're just digging up the grave of the globe, like the coffin of the globe, lining it with C4, and we're absolutely blowing it beyond all recognition. There's no longer any remnants left of the globe. If you understand what we're doing with celestial navigation, how we use the sextant, how we use flat maps to plot our position, never using a globe. This is fantastic. Thank you so much for coming on and explaining this to people, Rob. Like, this is, yeah, definitely a one of the strongest proofs that we're not living on a globe.
Yeah, I agree. Thank you for having me.
And I mean,
Sure.
yeah, no, it's been a pleasure as all mine. And I mean, if anyone wants to rebut this, give us the map that you were actually plotting the GP points on, the circles of equialtitude globers. If you think that we're doing this incorrectly, if we're not using a Mercator map, what map are we actually using, globe believers? That's what you have to come up with. What map are we actually using? And then Rob can do this same thing. We can start with the flat map, put the circles of equal altitude onto that flat map, because that's what we're doing in every instance, and then Rob will wrap around your globe, and you will still get the salty teardrops here, won't we, Rob?
Yeah,
we'll go.
The teardrop of unequal altitude.
Exact. Teardrop of unequal altitude. Has anyone ever heard of that before? No. Because that's not what we're doing with celestial navigation. I mean, you hit it out of the park. Everyone, the link to Rob's channel is in the description. Please send him some love. Subscribe to Rob Durham today. Go to his channel. Go to watch his video. He puts concisely, how long's the video, Rob? It's about like 9-12 minutes or something.
Yeah, something like that.
Something like that. It's very concise. It goes through what we've just gone through today. We've just gone through it in a bit more detail, expanded a little bit, just played around with it a little bit. Rob's video is a killer. Everyone go and look it up. Rob Durham, link in his description. Unless there's anything else, Rob?
No, I'm all good. Thanks for having me,
Awesome.
Mitchell. It's been a pleasure.
Thank you so much, Rob. If you feel like the Earth turns on you, turn to Flat Earth School. It is around us 24/7 since the beginning of existence. I've been Mitchell from Australia. He's been Rob Durham. Thank you, Rob, for coming on Flat Earth School. You have schooled everyone on how we actually use the sextant. And it's, spoiler alert, we're never using the globe, are we, Rob?
Definitely not.
Catch you, mate.
See you later, mate.